Graphing absolute value functions. So this is a lot what we just did in class for our investigation. First, knowing what absolute value function is. The absolute value function is going to be shaped like a V, so like this. And our parent function would be when it goes through the vertex or the turning point, this point right here, when it goes through the origin. That's our parent function. And this is how a typically absolute value function is written. Like we did in class, when you subtract a number on the outside of the function, like this -2, that's going to move the function down. Moves down, or you could say that this would be a vertical translation down. Translation just means how did it move on the graph. This question says, how does this graph relate to my parent function? If I look here, it moved up 1, 2, 3, 4. So it went up 4. So if I'm going to write out the equation, this is my parent function. Whenever I add or subtract a number on the outside here, that's how it moves up and down. So then this would be a +4. So this would be my final answer of how did I write out that equation. So what is the graph of this equation? There's two ways you could do this. You could do it like we have done in class, where we make a table, x, y, and then pick points. If I pick -1, 0, 1, and then use this equation to solve my answers. But when I look at this problem, I see this +2, so that's only going to move my graph up 2. So instead of having my vertex at the origin, my vertex or my turning point is going to move up 2. So it's still going to be a V shape, except the turning point is moved up 2. And it should look like a V. Now we have problems inside of the function. When I say inside of the function, I mean in between my absolute value symbols. So inside the functions, in between my two lines. So if I'm going to graph this, when it's inside the function, it's hard to know where to start the graph. So I'm going to start the graph just because I know what the answer is. At -3, -4, -5, -6, and -7. So once I graph this, I'm going to figure out my y vertices are. So for the first one, I would just plug -7 into my equation, and then figure out -7 plus 5 is -2, and the absolute value of -2 is +2. So I have my table filled out. Now I'm going to plot my points. So at -3, I moved +2, so about right here. At -4, I moved +1. At -5, I didn't move up at all. At -6, I moved up 1. At -7, I moved up 2. So here's my graph. So when I have numbers inside my graph, when I look at this, my original, remember, would be if it was at the origin. It moved left 5. Now, typically when you see this, you would think, oh, that's probably going to be moving a positive number. When it's inside the function, it moves opposite. Left or right. So since it says positive, it's actually going to move negative. If it said negative, it would actually move positive. So here I want to actually write out my equation. So remember, this is my parent function right here. So how should I change this so it moves right? So if I think of my graph, moving right would be moving positive. So remember, inside of the function, y equals, I have to make sure to do the opposite. So instead of writing positive, I'm going to write negative. And negative, and I want to move 9 units, so I have to subtract 9 units there. If I want to move 4 units to the left, remember if I were to draw my graph here, moving left is moving negative. So I actually have to write out a positive because it's opposite on the inside of the function. So this is what that would look like. So in closing, when you have a parent function like this, and if I have my translations, I have two translations here. I have either a -h, and the reason why I have put minus is because inside the function, remember, it's opposite, or a +k. H is going to move left or right, and it's going to be opposite shown. And K is going to move up or down, and it's going to be whatever's shown is how it's going to move. So if it says positive 3, then it would be going up 3. Make sure you fill out your Google Doc form and submit your answers.